this is a graphing problem. You're going to graph this problem. Now, luckily, it is way easier than the stuff we were doing yesterday. The stuff we were doing yesterday, remember we had to find the factors. We didn't know what these were, and now we have them. So every factor gives us an x-intercept. Every factor puts a dot on the x-axis. So we're going to have a dot clearly at -3, at 4, but there's also a dot at 0. When you have a plane x, that is like x minus 0 or x plus 0. It really doesn't matter. Every x gives you a dot. So this is like having a factor of x minus 0. Now, no one ever writes it that way, but that's what it's like. That's what it's the same as. So you have a dot at the origin, a dot at -3, and a dot at 4. Okay? Then, all the dots are there. Now we're going to sketch our picture. Nothing is squared, so we're not going to be bouncing or anything like that. But there is a negative out in front. What does a negative out in front do to our picture? Turns it upside down. Now, if you multiplied this all out, it would be x cubed. X cubed normally starts down here. But because of the negative, everything's upside down, it's going to start up here. So we're going to start up here, pass through, pass through, pass through. Connect your dots, passing through all of them, and that's that. Okay? So 2 things to keep in mind from that problem. It's a pretty simple problem, but the x threw some of you, the plane x, remember that just means the origin. And then you have to pay attention to the negative. The negative is going to turn your picture upside down. Okay? All right, so that's that. Now, we need to get back to our notes, and we're going to start with a quick review. David, I cannot count you present. I don't know if David's not going to get present. All right, so back to our notes, and we're going to do a couple quick division problems. Remember, yesterday we were practicing the process of synthetic division. So we're ready for B. This is number 5B on the back of page 18 in our notes. We are dividing this problem using synthetic division. All right, so you got to put a number in the box out here, right? What's going to go in the box?
1.
Not 1, -1. Remember, when you have the parentheses, the number that goes in the box is the same number that if you were graphing that parentheses, wouldn't the dot go at -1? Wherever the dot goes is what goes in the box. It's the same thing. Okay? So the opposite of this is what goes in the box every single time. Now, the numbers in the problem, we just have to be careful when we write these down that no powers are missing. Well, there's 3, 2, 1. Is anything missing? No. Well, and there's no x to the 5th, x to the 6th, x to the 7th either. And I don't care what came before. Whatever the power is that's starting there, that's number 1. And then everything has to be there after that. Also, Also, don't forget to include the negative when you write it down. Okay, then we draw our line and bring this straight down, right? Don't forget to bring that first number straight down. Okay, then we multiply -1, and then we add. And then we multiply, and we add, and then we multiply, and we add. So did I do okay? Sometimes I make mistakes when I do that. I don't need 0 on this one. I need 0 if I'm looking for the factors. But all this is, Jameson, is a division problem. Now, Jameson, the fact that isn't a 0 tells me this is not a factor, right? So if I were doing that guessing thing, this would not be a good guess because it didn't give me a 0. But this problem is simply the division. We're just dividing. So what's my answer? Well, that would be the remainder, but what about the rest of the answer? 3x squared minus 10x plus 19, and then my remainder stuck on the end. That's exactly right. That's the remainder. And all this, though, is part of the answer of the division problem. Why is it x to the second? Because it goes down a power. When you do the division, your answer is down a power from whatever you started with. All right, so let's do the last one. That's another just plain division. We're not doing anything special, we're just dividing. So what's going to go in the box for problem C? What goes in the box? 1. Yep. Everybody see 1 goes in the box? And then we have 2, -8, 1, and 4. Is anything missing? Do I have all my powers up here for this one? Yeah. 3, 2, 1? Yeah. So no zeros necessary. 2 comes straight down. All right, go ahead. Do the division. See what you come up with. Remember, your answer should look like this, something like this. This is the answer. So I know it's going to be 2x squared. You already have it, Jaden?
Yep.
What is it, 2x squared?
Minus 6x minus 5, remainder -1 over x.
That's what Jaden got. I don't know, is anybody matching that? I see some nods. That's what everybody got. All right, quickly, 1 times 2 is 2, add -6, add -5, add -1. I think he's exactly right. Anybody have a question about that process of synthetic division? All right, we have a couple of more things to talk about, and then we'll be done with these notes. So, let's look at the next page. And the question is x minus 1 a factor of this polynomial? What?
Now we have to find a 0.
Now we want to know if we get a 0 or not. That's exactly right. Because if it's a factor, when we divide by x minus 1, we should get a remainder of 0, right? So that's the question. It says, is this a factor? Well, if it is, we'll get a 0 in this spot. So what are we going to do?
Wait, can we do this one?
What?
We group this one.
Oh, well, and Jameson says, I might just try to factor this problem by grouping and see if this is one of the things that comes out. You absolutely can do that, Jameson. Probably will take longer, but yeah, you can try it, absolutely. And good observation, by the way. Good observation, that's a groupable problem. All right, I'm gonna go ahead and do the division though, because I think that's gonna be faster for me. If I wanna know if something is a factor, that simply means it divides in with no remainder. So doing this division, let's see if we get a 0. We did. Now, in this problem, we don't care about all this other stuff. All we care about is that. Because that tells me I have a factor. So the answer is yes, because the remainder is 0. Does everybody get that if the remainder is 0, you have a factor? Like 8 goes into 16 evenly, no remainder, it's a factor. Caroline?
So if you wanted to do it the other way, could you like show us how? Or is this just like the better way?
No, I'm going to show you another way. What Jameson wants to do is factor this by grouping.
That's what I
Yeah, that's fine. That's fine. Here's the problem. Some of our problems don't factor by grouping, right? So that isn't always going to work because it's possible to have a factor even if your problem doesn't factor by grouping, okay? But for this particular problem, if you want to factor it, that's fine. But don't rely on that method every time because it won't work every time, but it will work here.
Can you show me how you would factor it or no?
Well, I want to show you something else too. I don't want to confuse everybody because I would not recommend doing these problems that way. I wouldn't recommend it because it doesn't work all the time. I would recommend doing the division and getting a 0. That will, every single time, that will tell you if it's a factor. But I want to show you something else that's a little bit interesting. That might come in handy. It always works also. But it's something we haven't really talked about. But it's kind of an important idea. Let's suppose that thing that we're dividing there, that big part of the problem, let's suppose that's a function. And instead of dividing by 1, let's suppose I plugged 1 in. Well, you know how to do that. You just plug 1 in. So you have 1 cubed, which is 1, minus 1 squared, which is 1, minus 4 times 1, plus 4. What does that all add up to? Zero. Thank you. This is the remainder. So you can actually find the remainder by plugging in if you don't want to divide. Every time, that will work. Now, what that doesn't do, it doesn't give you the rest of the problem. We don't need it in this case. All it gives you is the remainder. So you can always find the remainder by dividing, but you can also find the remainder by doing this. Okay? Now, I don't want you to write this down. I just want you to watch for a minute. Because some of you are thinking, why in the heck would I ever want to mess around with this? I can just do my synthetic division. Don't write this down. I just want you to think about this for a second. What if the problem said, is x plus 1 a factor of 2x to the 99 minus 3x to the 70th plus 4x cubed minus 8x plus 1. Now, can you find out if something is a factor by dividing? Sure. But what would be the hassle or the downside of dividing in this problem?
We'll need like 90 zeros.
There's like 90 zeros, he says. There's a bunch of zeros. So if you were going to do synthetic division, you'd put -1 out here in the box, and then you'd have your 2, and then you'd have a whole bunch of zeros, right? And that would be a very long and complicated problem. Could you do it? Yes. But it would take a long time and a lot of space. So if I want to know if something is a factor, then what I want to know is the remainder 0? One way of finding the remainder is dividing, but another way of finding the remainder is just plugging the number in. So I would plug in -1 for all my x's, and this would not be hard, but at least it'd be a whole lot easier than the division. And I'll just work all that out, and if it comes out to be 0, the answer is yes. So let's see. Negative to an odd is negative, so that's going to be -2. This is going to be positive. It's going to be -3. That'll be negative, positive, positive. What does that add up to? What's the answer to the question? Yeah. So is this a factor of this? Yes, it is. Because when I plugged in -1, I got 0, and that number represents the remainder. Okay, your hand up, Farrell?
If it doesn't equal 0.
Then the answer is no, it isn't a factor. So if I had done all this work and this had come out to be 3, then that means the remainder is 3. That means if I did the division, the remainder would be 3. That means this is not a factor. Because the only way something can be a factor is if the remainder is 0. Okay? All right. So that's a little aside there, something for you to kind of store back here in case you ever have to deal with a big number. But there's one more of these, so here we go. Is x plus 2 a factor of this? So we want to know, is x plus 2 a factor? All right, so what are our options? What do you want to do? Division? We can do division. What would go in the box if we were doing division? -2. Also, watch up here very carefully. That would be a 1, but I'm going to need a 0, right? Right?
Plus 0, right? And then the -3. Like you would add the 0 and then minus.
Yeah.
It would be
Yep, this is the order that it's in.
And that can always be different, doesn't matter.
What?
Is that the order that doesn't matter, or is it the?
The
Oh, I'm thinking of the
exponent
factors.
order matters.
I'm thinking of the factors that doesn't matter. That's
Right.
what I'm saying.
These numbers have to be in the order of their exponents, going down in order. All right, so now I'm going to divide. If I did that right, this is not a factor because the remainder is -15. And if it's a factor, the remainder has to be 0. And it's not. Okay? We could also, I'm just going to do this just to make sure we're clear on it. We could also plug -2 in for the x's. You don't have to do this, kids, but it is something that comes in handy from time to time. So we could, instead of doing the division, we could plug -2 in, and using your calculator, you can, did I do that right? That's not 24, that's 12. And that's, yeah, so that is, oh shoot, that's not right. That shouldn't have happened that way.
But you still have to have the 0 actually.
No, I don't need to do that, so is this 16, that's 4. It's minus 12. There we go. Is that better? That's -15. That should always equal whatever the remainder was.
So if you take the x plus 2, make it a negative, and then plug in all the x's,
You're gonna get the same numbers right here, yeah. Yep.
So would you rather do that over division or?
You can, it's whatever you like best. Now, depending on how many numbers there are in the division, this might be faster, but really, this was pretty fast too, with this kind of not being any numbers there, that was pretty fast too. Either way is fine. To answer this particular question, it doesn't matter which way you do it. But remember, whatever you would put in the box, that's the number that you plug in. Okay, number 7, 3 more problems, and then these notes are over because the next notes or the next slide there is in the next section. So let's just see if we get through these 3 problems. We want to know, you guys always want to take a break. You guys are in perpetual break.
It's game day.
I know it's, every day is game day in math land.
Math land is not a thing.
I don't like that.
Hey, I like math when
That's fine.
because money is math, and I like money.
Yeah, math makes the world go round, and we know that.
Not
That's why people came up with calculators.
Okay, now, this question is very similar to what we did yesterday, but it's easier. Because yesterday, I gave you a problem like this, and I said find the zeros. Jameson, what are you doing, honey? Okay, what are you doing on your calculator though?
No, I was bringing it up to the black hole we just did.
Okay. All right, go ahead. Yesterday, all I gave you was this and said, okay, find the zeros. And so we just started guessing numbers until we found them, right? Today, it's easier because I'm telling you one of the answers. There will be 3 answers, right? X cubed, 3 answers. I'm telling you one of them. So you don't have to guess. I already did that work. I'm telling you that number is one of the answers. How could we then go on and find the other 2? What? Well, not quite plug it in.
Do synthetic division.
Divide it out. Because if I plug it in, I'm going to get 0. But it's the other part of the problem I need, not the remainder. So division is the way we want to go. So we're going to do the division. And those of you that don't know what's going on, just stop and think about this for a minute. When,
I thought you said no guessing.
Because it already tells you.
I'm not guessing. I don't need to guess.
Zero coming in.
Because if I plug it in for the x's, I will get 0.
No.
Well, but I already
You want
know
the other
that's an
zeros.
answer. I have to find the other answers. So plugging this in isn't going to help me find the other answers. It's going to prove that's an answer, but I already know that. So I'm going to divide it out. This is not a factor, you guys. This is the dot on the number line. It says x equals 1. If that's the dot on the number line, then that's the number that gets divided by. The factor would be x minus 1, but okay, that isn't what I want. I need to know the dot, the answer is 0, or is 1. So I'm going to do this division. And what comes out is exactly what I knew would happen, because that's a dot, that's a root. The part I'm interested in is right here, because this is what's going to give me the other two answers. How can I get the other two answers? Well, I can factor them, or I could use the quadratic formula. Either way, it doesn't matter. After you do the division, this is a quadratic, so you're going to end up able to use the quadratic formula if that's easier for you. This does factor, but some of you aren't very good at factoring, so you can use the quadratic formula, and it's going to give you the other two answers, which are -2 and -1/3. This is easier than what we did yesterday, because what we did yesterday, you had nothing to start with. You had to guess. I've done the guessing for you, so all you have to do is divide it out. And when you divide it out, solve what's left. And that's where you get your other two answers, right there. It's kind of easy.
So for this one, I wanted it to be -1 because -2 minus plus should be -1.
What now?
No, for this minus basis. Did we want it to be -1?
Yeah, I want what to be -1?
Wait.
I want
Just
this to
kidding,
be
just kidding,
0.
just kidding.
That has to be 0. If
Just got it
something
mixed up.
is a root or a 0 or a factor, the remainder has to be 0. Farrell?
Alright, so why do sometimes we multiply and sometimes we add?
Okay, I'm not sure I know what are you referring to? Synthetic division?
Why do sometimes we multiply and sometimes we add?
Okay, the process says you multiply these two together, write the answer here, and add. You multiply these two together, write the answer here, and add. That's the process. You multiply on the diagonal here, and then you add the straight up and down. Okay, let's look at the next one. The next one says, we have this big long problem, but we know that 8 is a 0. So we need to find the other zeros. I don't know what happened to Jamel. Okay, so we have to find the other zeros. So,
I think you might know.
so thinking about what we just did, what do you think would be the way to go here? And divide by what? What's going to go in the box? 8. I know when I do this that I better end up with a 0 right here, right? So let's see if we do. Let's bring the 1 straight down. Add, we get 4. Add, we get -12. 12, there it is, negative 96. Those numbers are kind of big. Use a calculator if you need to. But we knew this was going to happen. This isn't the interesting part this time. This is the interesting part. Because that's where my other answers are coming from. So this would be x to the second plus 4x minus 12.
Why do sometimes we flip it when we put it in the box? Like why sometimes we make it negative and something different?
Okay, you only make it negative when it's written this way. When it's written like a factor. Is that the way this is written? No. When it says x equals, that's where the dot goes. Okay? So try to make the connection. You won't have any confusion. If it says x equals 8, that means there's a dot right there. If there's a dot right there, that's what goes in the box. The dot and the box are the same. If I had this, that would tell me that the dot goes at 8, right? Yeah. All right, so I'm either going to use the quadratic formula or factor this one. This one factors easily, but again, you can use the quadratic formula if you want to. So what is the answer to the question? What are the other two zeros? This was one. One of them is negative 6 and the other one is 2. Those are the answers to the question. Because the question is, what are the zeros? In other words, what are the dots? The dots would be at negative 6 and positive 2. Yep.
For the next problem, can you do one with the quadratic?
No, because it probably factors, and that's the way we should be doing it and practicing that to get ready for the next section where we're going to have to factor. Well, I hope not. All right, let's see what we've got here. All right, so they tell me that one of my zeros is 3. So I'm going to divide that out. We know to divide that out. We know what's going to happen, or at least what better happen. And sure enough it did. We got a 0, which is exactly what we knew would happen since this was supposed to be a 0. This part's going to give us our other two answers. What is this? X squared plus 7x plus 10? Right? So we need to set up a reverse FOIL. Right? Yep, we need things that multiply together to give me 10 and add up to give me 7, so that would be 2 and 5. Because if you FOIL this back together, that's what you would end up with. That's the key. Factoring is just unfoiling. So what are the other two roots of the problem? Negative 2 and negative 5. So the final answer, this is like all of our work, but the final answer is going to be negative 2 and negative 5. No, hang on a minute. All right? Okay, so that concludes our notes. So the next page starts the next step. So we're not doing that right now. So what I want you to do now is get out a sheet of notebook paper, if you would please. Oh, Gabe's back. Get a sheet of notebook paper out, if you would. I'm going to have you write a couple of things down. have you write 3 things down. So on your piece of paper, kind of divide it up into thirds. So you've got 1, 2, 3. But you write these 3 things down. Alright, so write these 3 things down. Don't panic, don't panic. Everybody's writing these 3 things down. On your sheet of notebook paper. Make sure you copied it right. Pluses and minuses make a difference, so double check, make sure you got everything where it's supposed to be. Alright, everybody got these copied down? Alright, and everybody's got your notes out, right? We want to have our notes out. Yep. Okay, so for the first problem, I want you to make a list of the PRRs. Use your notes, make a list of the PRRs for the first problem. For the second problem, I want you to sketch it. So I want you to set up an axis system, put some dots on there and sketch it. And for the third problem, I want you to use synthetic division. Okay, just divide. Okay? So let's take a minute and have everybody get a good start on those. Because then we'll partner up and see how we did. Use your notes. If you've forgotten how to do something, go back and look at your notes. See if you can figure it out. PRRs we just talked about yesterday. Graphing, I'm not answering any questions. Graphing was a couple days before that. Minutes here. Gabe, where did you go?
My Wi-Fi was messed up, so I unplugged it and followed with it.
Okay. All right, good deal.
I sent you an email too.
Okay.
I need.
Okay, now what I want you to do is wherever you're at, however far you've gotten, I want you to, with your mask fully up and maintaining some distance, I want you to partner up with the person you're across from. Okay? Person you're across from and compare your answers. You three will have to do it together since it's video. So compare our answers with our partner. Help each other. Compare answers. You guys can converse with each other. Compare your answers. Talk about it.
First one I got 110.25 over 1.
Yeah, the only one that bounced.
And the second one I did was a graph, and I bounced off the board. And then the last one I got 3x cubed plus, or 3x cubed plus 3x squared plus 8x minus our remainder 1 over x over 1.
For this last problem, make sure you have written out your answer. It's not just the division, it's what is your answer. Help each other. Oops. Actually, then, why don't you
So we're mixed match cookies around this for? I'm more mixed match cookies.
What does that mean?
One black and blue.
Miss Ford.
I don't know.
Okay. So reason for that?
I always do it.
Oh, okay. Oh, I'm not asking any questions. This is a partner activity. All right, we're gonna stay 1 more minute with this partner, and then we're gonna switch with a different partner. Okay, well, you gotta work it out. You are gonna work with a different partner. I'm gonna switch you up there in a minute.
Where, oh. How do you know who you
Okay, now I want the middle of the room to pair up. So you'll each Kennedy and Jane will pair up this way, and then the outside to pair up. So Miriam, you'll come over with Mary Kate, and John, you'll go over with Ella, and Katie, you'll go with Trey. Okay. So come on, help each other.
And see the negative test? Yeah.
I know what I did. I got the 0.
I didn't see the negative, and now we're doing minus.
God, and then there's reserves.
You right, like, I know that's why I'm
Okay, 1 more minute.
Yeah, I know, most of the people got this.
Okay, guys. Let's put your name on your paper and pass it up. We're gonna go over these real quick. Yep, we're passing them up. Turn them in. Name on it. Right now.
The graph. I didn't see the negative.
Well, we're gonna find out real quick how we did.
Resource, ceramics, stay home. No, I'm not like you.
All right, guys, two things.
I got
All right, we gotta go over these, so we're not gonna get out of here on time. So here's what we do with the first one, real easy. These problems these are all easy, short problems. It shouldn't have taken you too long. So let's fill in the gaps if there's something you don't know. Guys, you need to take a picture of your work and send it to me now. Okay. So the PRRs, factors of last. So that would be 10, 5, 2, and 1 over factors of 1. So the answer is basically just plus or minus 10, plus or minus 5, plus or minus 2, and plus or minus 1. That's it. Those are the PRRs. If we had a problem where we needed to guess, those would be the numbers that we would be guessing, right? That's what our PRRs are. Sketching. This one was much easier than yesterday because it's already factored. So you put a dot at -5, you put a dot at -2, you put a dot at 3, and that's it. That's it for the dots. Then you count up your x's. So 1, 2, 3, 4 x's. That means it's even. X to the 4th is even. Evens look like this. It's x squared, x to the 4th, x to the 6th, all look like that. So it should start up here. But because of that, it starts down here.
Really?
And when it hits the -5, it just goes right through. When it hits the -2, it goes right through. When it hits the 3, though, it bounces off.
Yeah, I did.
Anybody get that right?
Like, so what did they go down? I did it both down.
You had the bottom going up.
Even powers are up.
Okay,
But when you put a negative in front of it, it's down.
thank you.
And then our division problem, you did 1 divided into 3, 0. Did you catch the 0? 5, -8, 1.
Yeah.
So, if I, oh my gosh, did that come out to be, oh no, it didn't. Is that what you got?
Yeah.
So that would be 3x to the 3rd plus 3x squared plus 8x. You can say plus 0 if you want, but you don't need to. And then plus 1 over x minus 1. Right?
So we have to
I'm
go
down
down
for that part.
I
So this is the answer. This is the answer to the division. What?
How do you know if you bring the 3 straight down? Where is the 0 in the problem?
Here,
It doesn't matter. This whole graph.
look at the powers, Carol. It goes from 4 to 2. You have to have every power represented. So the 3 is missing, so it has a 0 in there. All right, clear off your desks. I'm going to spray them. That was a good review of a few problems. Yes, it's going to be worth points. And it's also a good reminder of how important it is to take careful notes and how important it is to pay attention every single minute. Some of you guys, you get bored and you zone out. This is not a class that you should be doing that. You shouldn't do that in any class, honestly. Certainly not this one.